Okay, so I got cut off in the middle of that, so we're going to pick up where I left off on number 5, and then we'll continue. Since I had to rewrite everything, it's kind of, I just started here and then I taught the whole thing, but then I realized I didn't record, so we'll pick up at number 5. Okay, so we're just finding the first 5 terms. So I have the first one is 3. And then each time I'm going to multiply by x over 5. So then the second term would be 3x over 5. The third term, if I multiply this by x over 5, would be 3x squared over 25. Fourth term, I multiply this by x over 5, would be 3x to the third over 125. And then the fifth term would be 3x to the fourth over 625. Okay, next section, write an expression for the nth term, and then we're going to find the indicated term. So now we're actually going to start using this equation. We're going to use this equation for the next 2 problems. And then we'll start talking about the sum. Okay, so we have 2 parts. We have to write the expression and then find the indicated term. So if I want to write the expression, this would be AN equals, okay, and then I need A1, A1 is 4, times, and then I want R to the N minus 1. Okay, that is one part of your answer. The other part says then find the indicated term, so now you're going to plug 10n for n. So I would do 1/2 to the 9th power, because 10 minus 1 is 9. Then I'm going to multiply by 4, so I get 1 over 128. Okay, so you're writing the equation first, everything, we're just plugging it right in here, and then we're going to plug it in and solve. So for this one, A1, I would have 500 times 1.02 to the n minus 1. Okay, and then you're going to plug 40 in for n, so 40 minus 1 is 39. So I do 1.02 to the 39th times 500. Now this does not come out perfectly, so just round to a couple decimal places. You get 1082.37. Okay. Okay, 8 and 9 are similar, except for you're just finding the indicated term. So like on number 8, we're going to find the 9th term, and on number 9, we're going to find the 6th term. We're still going to use this equation, but we can just go straight in and plugging in n. Okay, everything's not given to us as clearly as it was on 6 and 7, but we still have everything we need. So like I need A1. Well, A1 is my first term. And then I'm going to need R. Well, if you don't know R, like you can't look at it and find it, how you find it is you take the second number divided by the first number. So 21 divided by 7 would be 3. And I know this number is going to be my n. So I just plug everything in. So I would have A1, so 7 times, and then I have my 3 to the 9 minus 1. So 9 minus 1 would be 8, so I'm going to do 3 to the 8th, and then multiply by 7. So that would be 45,927. Okay, now number 9 is a little bit trickier because it doesn't give me A1 or R. It's a little different than arithmetic because you can't just like subtract and divide. So what we're going to do is we have to plug in what we have into this formula to find R, and then we can work backwards. So if I want to do that, I'm going to make this last term, the biggest one, so A4, A7, A7 would be bigger, equal to my first term, this would be negative 18. Okay, we don't know R, so we're going to leave R there. Okay, then I need it to the n minus 1. Okay, how many terms do I have? I have the 4th term through the 7th. So 4, 5, 6, 7. So this would be 4 minus 1. So I'm going to solve for R, so I'd have 2/3 was negative 18 r to the third. So I would divide by negative 18. So I would get negative 1 over 27 equals r to the third. And then I would take the cubed root to get rid of that to find r. Okay, so r is negative 1/3. I need to find the sixth term. So I have the seventh term. Negative 1/3 is what you multiply to get to the next term. So if I want to go backwards, you would divide. So if I want to figure out, okay, what is a to the sixth term, and I have the seventh term, I would take 2/3 divided by my r, because I'm going backwards. Well, if I take 2/3 divided by negative 1/3, then that means my sixth term is going to be negative 2. Okay, going forward you multiply, but if you have to go backwards, which was the quickest way on this one, is you would divide. Okay, we could have started with 4, and we could have multiplied by negative 1/3, and then multiplied by negative 1/3 again, then we would have gotten the same answer. Okay, now we're going to move on to sums. You have two sum formulas depending on what you're talking about. The first one is the sum of a finite sequence. The second one is the sum of an infinite. Infinite means goes on forever. Okay, the biggest thing, we're going to talk about finite now. You should know what everything is on the terms. Like A1 is the first term, R is your common ratio, N is the number of terms. So the most important thing is the starting point has to be 1. So that means when I'm looking at these numbers have to be 1. Okay, so we're going to run into a problem on number 12 because number 12 is not 1. So we're still going to use the formula, but it's going to be adjusted a little bit. Okay, these equations are set up just like this inside the summation. So if I want to find my A1 is the number in front. So A1 here would be 1, the A1 here would be 5. The R is the number to the power. So R here would be 2, R here would be negative 1/3. To find N on summations, remember you take the top number minus the bottom number plus 1. Okay, so if I want to plug these in, my sum, I need A1 on the outside, well there's nothing here, so it'll be 1 times, okay, 1 minus R, so 1 minus, this is my R, so 2, and I need that to the nth power, so 9 minus 1 plus 1 would be 9 over 1 minus R. Biggest thing, make sure you follow your order of operations. Do your exponent first before you do subtracting. So I would do 2 to the 9th, which is 5/12, so I'll say 1 minus 5/12. Then I'm going to divide. Well, 1 minus 2 is negative 1, so I'm going to divide that by negative 1. And then I'm going to multiply by 1. So that means my sum would be 511. Okay, we'll do the same thing on number 11 because the starting point is 1. So my A1 here would be 5. Then I'd have 1 minus, my R is negative 1/3. Okay, my N. 10 minus 1 plus 1. So 10 minus 1 is 9, plus 1 is 10. Over 1 minus negative 1/3, which will turn into 1 plus 1/3. Okay, same thing. You have to figure this out first. Now, because this is going to be a really small decimal, a really small fraction, it's going to convert to a decimal on your calculator. If they won't convert, that's fine. Just round them. But if it can come out perfectly, or like you can simplify it. I know this one won't because that'll be a very, very small fraction. So negative 1 to the third, negative 1/3 to the 10th. Okay, and then I would take 1 minus that answer, divided by, 1 plus 1/3 would be 1 1/3. And then I'm going to multiply by 5. So I would get, I'm going to round since it's not perfect, 3.75. Okay, number 12. Number 12 is different because it doesn't start with 1. Okay, so what we're going to have to do is we're going to have to find the 0 term first. So I'm going to plug in 0. 1.06 to the 0 is 1 times 300 would be 300. Plus, okay, then we're going to use this formula. Okay, but I can't, this is not a 1, because this is what the number is when this is 0. So what I'm going to do is I'm going to have to find a 1. So it would be 1.06 to the first, which is 1.06, times 300, which would be 318, times 1 minus, okay, this is still your R, so 1.06, okay, to the n. This now became a 1. So this, because we already took off the 0 term. So 5 minus 1, 4, plus 1 would be 5, over 1 minus 1.06. So after you find out what this is, we're just going to add 300 to it. So 1.06 to the 5th, 1 minus that answer, divided by, well, 1 minus 1.6. No, it is, yeah. And then I'm going to multiply that by 318. Okay, this does not come out perfectly. When you get done with that, then you're going to add 300, and you're going to get your answer, which is 2092.60. Okay, we have a few more summation problems, so I'm going to write those down. Okay, so the first part, use summation notation to write the sum. Okay, so what you're doing is they're giving you the answer, you're going to work backwards. So when you're working backwards, first thing we know is, because it's a finite, we know that we're going to have to start with 1. So we're going to start here with 1. Okay, I I need an equation that looks like this. So I know A1 is my first term. Okay, then I need to know R. If you can't find, if you don't know R right off the top of your bat, you always take the second number divided by the first number. So R is 3. And then I have n minus 1. Okay, easiest way to find the top number is to plug numbers in for n until you get this answer. Okay, there you can use the formula to solve. I think this is the easiest way, so I'm just going to go with this way. So let's just say I try 5. Well, if I make 5n, 5 minus 1 be 4, so it'll be 3 to the 4th times 5, which is 405, so that's not big enough. So I'm going to try 6. Well, 6 minus 1 is 5, so I'm going to do 3 to the 5th times 5, and I get 12/15. Still not big enough, so I'm going to try where n is 7. So 7 minus 1 would be 6, so I'll do 3 to the 6th times 5, and I get my answer. So I had n is 7, so then my number up there would be 7. Okay, that's the easiest way than trying to use the formula, is just to guess until you get to that answer. Okay, same thing on this one. Summation, you know we're going to start at 1. My first term is 0.1. Okay, R, figure out what you multiply by to get to the next term. If you don't know, can't do it in your head, you would take 0.4, divide by 0.1, you're going to get 4 to the n minus 1. Okay, figure out a number up here. Let's plug numbers in for n. So let's try, I'm going to try, 5. Okay, so 5 minus 1 would be 4. So I'm going to do 4 to the 4th times 0.1. That's not big enough. So I'm going to try where n is 6. So if n is 6, 6 minus 1 would be 5. And that gives me my right answer, so I know my n, where it ends up, is 6. Okay, those are for finite. Last part, infinite. Your formula for infinite, here's the important thing. R, your common ratio, has to be between -1 and 1. If it is not, then the infinite does not exist. Okay? All your formula is you're taking the first term divided by 1 minus R. Okay, when you're looking at the summations, R is the number that's to the exponent. So this is R, and this is R. This one's not a series, or not written as summation, so we'll do that one last. Okay, 1/2. That's between -1 and 1. So I can find the sum. So the first term, so you plug in the bottom number. So if I put in 0, 1/2 to the 0 is 1. Okay, then I'm going to divide by 1 minus R. So 1 minus half is half. 1 divided by a half would be 2. Okay. Then if I do this one, 0.9 is between 1 and -1. I find my sum, I plug in, I find the first term, so I put in 0. 0.9 to the 0 is 1, times -3 is -3, over 1 minus 0.9. So that'd be -3 divided by 0.1, which would be -30. Okay, last one. It's written a little differently. So this is my A1. And then to find R, I would take the second term divided by the first term. So I get R is -3. Okay, well I have a problem. R is not between -1 and 1. So for this one, on your infinite, doesn't exist. And that's your answer. Okay, this will get you through the rest of the whole thing on 9-3.